Software-defined networking is a centralized, dynamic, and programmable network management technology that enables flexible traffic control and scalability. While SDN facilitates network administration through a centralized view of the underlying physical topology, tampering with this topology view can result in catastrophic damage to network management and security. In contrast to the existing localized topology poisoning attacks initiated from a data plane, a control plane topology poisoning can be a sophisticated globalized attack. Let's go over the link discover process on most SDN platforms. Suppose a 3-node controller cluster connecting with OpenFlow switches A and B. The leader controller first sends switch A packet out message encapsulating an LLDP packet and instructs switch A to send it by port 2. Switch B receives the LLDP packet by port 1. Because of the table miss flow entries on switch B, the LLDP packet is fed back to the controller by being encapsulated in a packet in message. Therefore, the controller learns a link from switch A port 2 to switch B port 1 by parsing the packet in message header and the LLDP payload. However, if one of the controllers in the cluster is malicious, it can manipulate discovered links precisely. In this 3-node topology, if the malicious controller set up a flow entry on C making the LLDP packet sent from switch A port 2 forward to its port 2 instead of sending it to the controller by the packet in message, the LLDP packet will be sent back to the controller by switch B not switch C, which leads a fabricated link from switch A port 2 to switch B port 1 to be discovered. We target manipulating links precisely and creating a realistic topology by maintaining the same degree sequence between the real and deceptive topologies. We call the flow entry influencing link discovery result a poisonous flow entry. We omit details of it because the poisonous flow entry design is not a trivial problem. Our poisonous flow entries are also designed to be stealthy without matching on LLDP Ethernet type, which hides them in millions of flow entries on a switch of practical networks. Let me demonstrate to you an OpenDaylight cluster setup and the potential control plane topology poisoning attack on it. First, let's configure the OpenDaylight cluster. We have 3 virtual machines. The first one is ODL1 with IP address 192.168.64.3. The second one is ODL2 with IP address 192.168.64.5. The third one is ODL3 with IP address 192.168.64.6. We configure files for the cluster. On ODL1, the host name is 64.3. Role name is member1. Seeds node are the addresses of the 3 machines, and those 3 machines share all types of data store. On ODL2, the host name is 64.5. Role name is member2. Seeds node are the addresses of the 3 machines. 3 machines share all types of data store. On ODL3, the host name is 64.6. Role name is member3. Seeds node are the addresses of the 3 machines. 3 machines share all types of data store. Now we are ready to start the OpenDaylight cluster. The role of ODL1 is the leader. The role of the ODL2 is a follower. The ODL3 is the other follower. Next, let's connect the mininet with ODL1. Okay, connected. Let's pull the topology from ODL1. Then pull the topology information from ODL2. And pull the topology information from ODL3. Until now, everything is normal. But if one of the peers in the cluster, let's say ODL3, has a failure and is offline, it exposes the vulnerability of the OpenDaylight cluster. Let's find out. First, we shut down ODL3. On another virtual machine ODL3 mal with the same IP address and the role name of ODL3, as long as one more IP address and a role name in the cluster are obtained and configured in the cluster files, the ODL3 mal can join the cluster. The other IP address and role name do not need to match each other to be accepted. Consequently, brute force guessing can be good enough to obtain and try the IP addresses and role names. Now, let's start the controller on the ODL3 mal virtual machine. We then read the role of it. Okay, it is a follower and the leader is member 1, which means it has joined the cluster. Now we pull the topology information. We are finally going to attack for real. Let's check out the flow entries before the attack. They are only table miss flow entries assisting link discovery. Now let me show you what is the goal of this attack. We are going to cause links from OpenFlow 1 port 3 to OpenFlow 4 port 2, OpenFlow 5 port 3 to OpenFlow 2 port 2, and OpenFlow 1 port 2 to OpenFlow 3 port 2. Let's start the attack. Even though ODL3 mal is not connecting with Mininet, the flow entries set up by it will be sent to the Mininet by ODL1 due to the consistent data store. Okay, the topology view changed on the ODL3 mal. The ODL2 also got the changed topology view. The ODL1 got the changed topology view as what we designed. At last, let's look at the flow entries to uncover the cause. The elaboratively designed poisonous flow entries are set up on the Mininet. They tamper with the LLDP packet forwarding path, which causes the topology information to be poisoned. Thank you.